So hello, everybody. Thank you for joining us today. I have our guest speaker here, Lucian, um,
Hello.
and I'm going to go ahead and make him the host so he can start sharing his slides, and we'll jump right into it. Anybody has any questions, please feel free to jump in and make this interactive event and have fun. All right, go ahead, Lucian, take it away here. Make you
Thank you.
there you go.
Yep. All right, let's see. Okay, can you see my screen?
Yep.
Yeah, great. All right, so hold on, let me start from here. Yeah. So this presentation was first presented at Czech Dreaming this year. So you can ignore the Czech Dreaming logo and all the sponsors in the presentation. I didn't have time to update the style of the spreadsheet. So yeah, this is my presentation. It's about 5 key ideas for building robust, reliable, and flexible REST API integration with Apex. We probably all did REST API integrations or Salesforce integration with an external system that uses REST API. And even if you didn't, this might be a good lesson for when you are actually going to start doing it when the project comes along. All right, these are the sponsors, doesn't matter. So I'm going to tell you the story of a project that I had to implement years ago when I started implementing REST API integrations. John is a real estate company owner, and he has a small team of people, and some of those people are accountants. And John is using Salesforce for managing his business, and he's using QuickBooks for accounting, right? But his accounting team is pretty frustrated because they have to manually copy data from Salesforce to QuickBooks. And I'm talking about client data, invoices, and that takes a lot of time, and it can lead to a lot of errors, right? When you manually copying data, at some point you will enter something wrong in it. So John wanted to make his team happy, and he asked me to implement an integration between his Salesforce org that he's using for his business and his QuickBooks account. And we can do that using the QuickBooks REST API from Salesforce, and we're going to implement that in Apex. So I said, yeah, sure, because I did it before, so I thought it's going to be easy to do it again for him. But it didn't go without problems. And that's why today I'm going to talk about the 5 lessons that I've learned implementing this integration. And at the end, I'm going to make your life easier when you implement your next integration, because I'm going to give you something that will give you a jump start on that integration. My name is Lucian. I'm a lead developer. I've been a Salesforce developer since 2011. I spent the last 5 to 6 years building a ton of REST API integrations from Apex. I kind of became a bit specialized in it. And currently, I'm the lead developer of Declarative Webhooks, which is a REST API integration app that allows you to build REST API integration, but without using code. So it's for admins. So, I'm here to share what I've learned all these years about REST API integrations. Okay, so I started working at John's integration, and I've looked for the old code that I had implemented before, and I realized that I could not use it easily. because my code was everywhere, in triggers, in Visual Force pages, Lightning Web Components, and I had to pick up all those pieces from everywhere and put them together in the new project. And I thought that that's not right. I have to build this in such a way that next time I need to build such an integration, I don't have to pick up pieces of code from different places. So that's when the first idea came to mind, which is one that you've probably heard about if you studied design patterns in Salesforce on Trailhead, for example. If you didn't, I recommend it because it's a very good trail about the design patterns. And the idea that came to me is one of those design patterns ideas, and that is to use separation of concerns. Separation of concerns is a concept in code that you use to separate the functionality of your code in different places, in different classes that do not overlap each other, and you can layer them as as layers in your application. And in this case, for REST API integrations, this is the structure of classes that I'm using ever since that project. And I'm going to describe each class that from this framework. So the first class is the API class. And this is a class that can make API calls to that specific integration. It contains methods and variables and all the code that is needed to make API calls, specific API calls to specific endpoints to that integration. And it doesn't contain any kind of logic. It doesn't contain any kind of connection between Salesforce objects and the external REST API. It's just for doing API calls. If you remember back in the day when we used WSDL to Apex to generate that Apex class that we were supposed to use to make WSDL SOAP calls through XML. The API class in concept is similar to that generated class. If you remember, that class only contained methods to make the call and helpers, helper classes to help you build the request and parse the response. The logic of the integration is going to happen in the helper class. This is where we're doing, for example, field mappings from Salesforce to the QuickBooks REST API request. And this is where you can also handle the response. Depending on the response from the REST API, you can update records and make changes to your Salesforce org. The methods from the helper class are called from other places that are going to trigger the integration logic, like triggers if the integration is automated, Lightning Web Components or Visual Force if the integration is real time, so the user will see the result, and basically all the places where you want to start the integration logic. If your integration also has an inbound component, so the external REST API is going to make calls back to you like webhooks, you can use an inbound webhook class, which is a pretty simple REST resource annotated class that can accept incoming calls, like get post calls, and from the external system, and it's able to send back the response. The inbound webhook class also calls the helper class for logic, for handling what's going to happen when that call is made. And to cover everything up, we build a test class. And yes, I know it's best practice to have a test class for each of the classes that we build. But in this case, I prefer to have only one test class that covers all these three classes. Because if you're trying to cover the helper class uses the API classes, and basically your API class will be already covered because the only code that uses the API class is the helper class. And then the inbound webhook class is just a simple method away, so we can include it in that test class. All right, let me show you an example of how this works. This is actual code. We have a trigger, let's say on the account, that when an account is created, it's supposed to send the data to QuickBooks. And the trigger will call a method in the QuickBooks helper called create customers. This method will extract the data from the account, will build the request, which will be sent to create customer in the QuickBooks API class. This one is the method that receives the request, makes the call using the make API call, which will be the only place in my code that actually makes HTTP calls, and all those other methods are using it. And then the response is generated back by create customer and sent back to create customers in the helper, where the appropriate action will be taken. For example, the QuickBooks customer ID will be stored on the account, on a field. The make API call is the only place that makes HTTP calls and is used by the other methods in the QuickBooks API class. And you'll see why in a few minutes. It's important to not repeat code, and the make API call will also do logging. All right, so I've implemented his project, John's project, and one morning he sends me a message and says, hey, can you send the account industry field through the API? And I said, sure, of course, why not? So I went to the code, I make changes to the code, I tested, updated the test classes, deployment, how it works. And it took about half a day to add this account industry field with all the testing and deployment. And I go back to John and say, yeah, done. You now have the account industry being synced. And he answers back, oh, thanks. Yeah. Can you also do the number of employees field? Okay, so we need to make this easier. That's when the second idea came to me, and that second idea is to make everything configurable. Well, not everything, but as much as you can to make changes to your application, to your integration faster, and possibly directly in production. I'm going to give you two examples of how to make everything configurable. One is to have a custom metadata or a custom setting that will hold the API settings, like the base URL, the credentials, customer key, customer secret, or username and password. So everything that you need in order to connect and make calls to that REST API, all the credentials that you need. And that makes sense, right? Because we all know that we're not supposed to keep those in code. So it's a good idea to have the QuickBooks, to have the custom metadata or the custom setting that holds that information. And the code will just use that. And this is a sample from the QuickBooks API class that I've built. You notice we'll have a settings property, which all it does is going to query that data from the QuickBooks API metadata. And this settings property will be used all over the code in the API class to set the credentials and the base URL and everything. Well, in this case, it's a name credential, so it will contain the name of the name credentials. to be used to make the calls. Another idea to make your integration configurable is something that would have helped me not take half a day to make a simple change to John's integration, and that's to make the field mapping configurable. I'm talking about the same thing like custom setting or custom metadata that contains sort of one-to-one between Salesforce fields and JSON nodes. In this case, you can see that we're mapping the name field into the display name fully qualified name when generating a customer in QuickBooks. And then I also have a static value that I can send through if I don't need to map something specifically. And in order to use this is the create customers method from the helper. And you notice the highlighted part of the code. It's looking through the QuickBooks mapping metadata, and it's actually putting values from it, from the account, from the fields on the account into the request node. And for the request, I'm using a map of string and object, which is very easy to serialize into JSON, which is what the QuickBooks API accepts, and also flexible enough for this kind of dynamic mapping. Well, not everything can be made configurable, not all the mappings. For example, if you see the difference between these two sample requests, on the left side, we have a very easy to configure JSON. There's a very simple one-to-one relationship between nodes and fields, for example. But on the right side, well, good luck making that configurable. Well, it's possible, but the amount of Apex code and time you spend making it configurable to handle all these JSON structures might not be worth it. So, take the decision based on your specific integration. Okay, so I've deployed that to production, and now it's easy to add new fields whenever John is asking me to add fields. But one other morning, I get another message from him just saying your integration is not working, with no other details. I mean, don't we love, messages like this from our clients? So I went through his org, and I've tested everything. I've made calls. I was able to look at Apex logs, the ones that were available. I couldn't find anything wrong. And yet he was right. One of the customers did not go through. So that's when I had this third idea when implementing the integration, which is to log every call, because it might have been the actual call that failed, getting back 500 or request timeout. And there was no way to know that for me. So I decided to log calls. Sorry. So I've created this custom object, QuickBooks call log, which will contain all the information from each log, like the URL, the method, the request body, response body, even headers if they are needed. And now I'm logging outbound calls, I'm logging inbound calls, and I'm logging failures. Of course, that would make sense, right? But we need to make sure that we are logging even if there are failures. Because, for example, what happens if you're adding the log and then your transaction, your log throws your Apex code throws an exception? The log gets rolled back, so it's gone from the database. So, make sure to use try catch to create the log, even if you're catching an exception, and make sure to cover all the if else's in your code to make sure you're always going to have a log. And here's how I decided to do it. If you remember that make API call from the API class, it's the only place where we're actually making HTTP calls. Well, this is one of the reasons. It's the only place, except, aside from not repeating code. And that is after you make the actual HTTP request to create the log and save it right away. And you notice I'm creating the, the log record. I'm adding the direction, the URL, the method, the request body, response body, but I'm not inserting the log yet. And that is because I might need to make another API call. And we know that we cannot initiate a call out after we make a DML. That will throw an exception. So we have to make sure to make all the calls before inserting the logs. So that's why we're gathering logs into a list and we're inserting it at the end after we're making all the calls. For example, if you want to create an invoice in QuickBooks, you need to have the customer first. So your code might try to create a customer if it's not already in there in QuickBooks. And then after the customer is successfully created, then create an invoice related to that customer. So that will make two calls in a single transaction. And if you add a log after the first call, the second call will not work and it will throw an exception. So we're creating the logs after the calls. So after finding that out, so after deploying and finding out that some of the calls were failing, I went back to John and said, it was the callout that is failing. And I was happy because I found the error, but he was not impressed. And he said, so what? Why was I not notified? Why didn't try again? And of course, he's right. I mean, we should have done something when the call failed. And that's when this fourth idea came to mind, which is to handle the API failures. Because it's not a question of if your API will fail, your callout will fail, it's when your callout will fail. It's just a matter of time. Callouts will always fail. Integrations always fail for a bunch of reasons, like network reasons, for example, or server unavailability. It can be a lot of reasons, but they will fail and you have to handle that. And there are a few options here. For example, if the integration is synchronous, so it happens in a Visualforce page, it happens in a Lightning Web Component, so the user sees the result. You can just show the result in the interface and maybe give them some options to try again. If the integration is asynchronous, so it happens initiated by a flow, by a trigger, there are a few options here too. One of them is to notify an admin. And you can do that through Slack, through Chatter, or email, whichever the client prefers. The Slack one will require a new integration with Slack, of course. There are options to do it with Chatter or email. Or you might want to just implement a retry. And I'm going to show you an example of that. If you remember the now famous create customers method from the helper that receives the account that needs to be sent to QuickBooks. And if you noticed, we're first trying to create a customer by calling the QuickBooks API create customer method. And then if it's not successful, we add it to a failed IDs list. And then if that failed ID list is not empty, it means some of them failed and we need to reschedule a retry. And I'm using a simple schedulable class that does nothing other than call create customers again with the same IDs that failed. And in this case, we just schedule it to run again in 5 minutes. And of course, it's you don't have to choose just one of these options. You can do a combination based on the situation. For example, you might want to retry 2 or 3 times, and if even the third time failed, you might want to notify an admin, or you can take the decision of which one to use based on the response. For example, if it's a timeout, you might want to initiate a retry. If it's the response is 401 or 403, which means it's not authenticated correctly, you might want to notify the admin immediately, because the lack of correct credentials will not be solved by just time. So you might want to let someone know that the integration cannot authenticate anymore. So take the decision based on your situation, and just know that there are a few options to handle the failures. Just make sure that you're handling them. Okay, so I've deployed that to production. Now John is happy that he's receiving emails when something fails, so he can try again manually. His accounting team is happy because they don't have to enter data anymore. John is happy, but I'm not yet. Will I have to go through all this the next time I'm implementing a REST API? Well, hopefully not. Hopefully I've learned from all this, and I want to start my next integration with a head start. So that's the 5th idea, which helps me more than the customer, and that is to build myself a framework that contains all these ideas by default whenever I start a new integration. And that framework will be a set of objects or custom metadata, a set of classes, like a simple API class, a simple, an empty helper class, or an inbound webhook class that does nothing yet but accept a call. So, a framework, the skeleton of an integration that I can start with. For example, the API class will contain the make API method with the logging, and I don't have to do it again, or I have a sample method for retrying. Everything being in this framework for my future integration, whatever that integration is going to be. And now, as promised, I'm going to give you a head start on your next integration. And this is it. I'm going to give you a few seconds, minutes to scan this if you want. It's a link to the code that I've used for this integration, for this presentation. And I mean, it doesn't contain the actual code that I've used with the client, but a very summarized code that uses all the ideas from this presentation, and is the code that I showed you in these slides. So take this, download it, study it, make it your own. You don't have to use it, but maybe take the ideas from it. Just make sure that your next integration is going to go a lot smoother with these ideas. So I've made my integration more flexible because I made everything configurable. I made my code easy to move because I used the separation of concerns. I made the application more reliable, more robust because I'm logging calls and I'm handling API failures. And I'm making my life easier for the next integration because I've built myself a framework that I can start from next time I'm working at an integration. So now everybody's happy, including me. Thank you. Now I have a few resources. If you want to take a picture of it, it's not that much. It's a GitHub repository of the code that I've used, the same one that I've asked you to scan earlier. A link to the slides that you just seen, and a couple of my social media handles if you want to connect with me, or if you want to ask me anything in the future. And that was it. Now, if you have any questions, I'm happy to answer.
There was one question that came in from the chat. It looks
Okay.
like it was from Sai, but it looks like he may have left, but I'll go ahead and ask it anyway. He said, will the make API call work if we were to use name credentials?
Yes, this was specifically created for, well, this integration specifically used name credentials. Let me show you that. Let's see. There you go. So
yeah,
you see the third line from the highlighted code, set endpoint. That is the way you set name credentials. For example, it starts with callout, and then you provide the name credentials, the name credential name, and we store that into our settings in the custom metadata in the settings. So we don't have, if we change the name, we don't have to change the code. And then the rest of the URL follows. So yeah, this code specifically works with name credentials, but of course you can set the endpoint to a regular URL.
one, yeah. Okay, perfect. Okay, yeah. If anybody else has any questions, you can ask them now, or you can use the chat feature if you prefer to do that. I think this was a great framework that you presented here. It's very similar to frameworks that I've built or my my team has built in the past. So great job.
Thank you.
Okay. All right. Well, we'll go ahead and conclude the call. Let me hit stop recording here real quick.